points lower and 6.9 points higher than the mean IQ of women. Okay, so I'm just saying I'm confident that men either have a lower or a higher IQ than women. Okay? Or the average, the mean, I gotta stop saying men in general and women in general. It's the average IQ of men is either lower or higher than the average IQ of women. Okay? That's essentially, you're not saying much. Okay? I guess you're saying a little bit, and you're saying that they're not extremely different. Okay? But you're not saying a whole lot here. Okay? So this sentence, this does not provide evidence that the mean IQs are different. And notice I'm writing does not provide evidence that they are different. Okay? Do not write this means that they're the same. Okay? Because it's not saying that. Do not say this provides evidence that they being mean IQs are the same. Okay? Do not say that. All we're saying is that based on my sample of 22 people, 10 men and 12 women, surprise, surprise, I don't have evidence that there's a difference. Okay? Basically, it's just not enough data for us to make a strong conclusion. Okay? Does this mean the population mean male IQ and population mean female IQ are the same? No. Okay? And in fact, if you looked at the entire population, it's probably not the same. All right? Yeah, I don't know which would be higher or lower, but
depending on the culture, right?
yeah, depending on the culture, right? Some cultures, they don't let the women go to school, and that's going to lower their IQ scores, or just lower what they would score on a test if they're even allowed to take a test, right? Whatever. Okay. So there's all sorts of things, right? If we looked at the entire population, they're probably not going to be exactly the same, but they might be very, very close. Okay. And the question is, if they're very, very close in the population, do we really need to know that they are just a tiny bit different? Let's say the true difference between male and female IQs is like 1 point in the population. Okay. Do we really need to know that, or is it okay to just treat them as being the same? Okay. I don't know. Right. It just depends on what you're trying to do. But when you did a study and you took 10 random men and 12 random women, and you got a difference between their samples to be 2 points, that is not enough evidence to prove, or does not provide evidence that the mean IQs of the population are different. Okay? So when you are looking at a confidence interval between for the difference between two means based on two samples, basically your conclusion depends on, does the confidence interval include 0 or not? Okay, so if the confidence interval for mu1 minus mu2 contains 0, then we do not have evidence that mu1 is different than mu2.
Are we making an assumption that the mu1 and mu2 are not drastically different for us to compare? If one is negative 100 and then to 1, 0 is covered, but obviously the spread is so huge, then it will be different.
Yeah, if it goes from negative 100 to 1, technically, okay, under what I'm teaching you here, you would say we do not have evidence, okay? However, all right, okay, well, I'll let you guys finish writing this down, and then I'll explain all this. Okay, so one thing I said earlier was that if we change t star, if we just choose a different level of confidence, what happens to our interval? It either gets wider or it gets smaller, right? Okay, so there is a possibility that let's say you have an interval, whatever it might be, negative 100 to 1, or even like negative, whatever it might be. Let's say you have an interval that goes from negative 5 to 0.1. Okay? Whatever the interval is, it goes from negative 5 to 0.1. Let's say this is 95% confidence. Okay? So according to just our strict, does it provide evidence or does it not provide evidence, if the interval for, again, this is an interval for mu1 minus mu2, because it contains 0, right? 0 is in between negative 5 and 0.1. This would say, from here we would say we do not have evidence that mu1 and mu2 are different. Okay? But if I just decrease my confidence, let's say I shrink it down to 90% confidence. Okay? I'm willing to give up some confidence to get a more precise interval. This might change maybe to negative 4.8 to negative 0.1. Okay? Just brings in the thing because my t star changes, right? Everything else stays the same. This t star just changes to a smaller number. So this could happen. Alright, if this happens, then suddenly we do have evidence, right? That mu1 and mu2 are different. Okay. But what's going on? It's the exact same data, and it's just, you know, when we say I have evidence or I don't have evidence, there's inherently some uncertainty in this statement that we're making, okay? Like, how much evidence do you have, right? I have enough evidence to say I'm 90% confident that there's a difference. But I don't have enough evidence to say I'm 95% confident that there's a difference. Okay? It's a little bit weird, right? But it's like, you know, it's like saying, you know, I've got a hunch that something's going to happen. Okay? You know, when it ends up being very close to this deciding factor thing, deciding point, then we can really specify basically how confident or how much we believe this evidence is telling us. Okay, so basically, I don't have enough evidence to be 95% confident, but I do have enough evidence to be 90% confident that there is a difference. Okay, so sometimes this happens, and then, you know, if you're the researcher and you've got to make a judgment call, that judgment call ends up in your hands, and you have to say, well, I don't know, you know. It doesn't happen too often, but sometimes it does. Okay. different, but that means there's also a possibility that the difference we see is just an artifact of that random sampling process. Okay. Yes.
Does the presence of 0 mean that the data isn't leaning a certain direction, it's leaning like both directions?
No. Well, what it is you're observing two samples, and the two samples don't have the same sample mean. Okay. And it's just that difference that you see between the sample means, is it different enough from 0? Okay. Is it big enough for us to say that difference is non-zero, it's non-negligible? Or is it actually close enough to 0 where we can say it's just a result of, it could be an artifact of the random sampling process. Okay. Yes?
When we read scientific journals and we see many findings, right? No, I've never seen they give a detailed analysis like this. So, are they required to do this kind of analysis before they say, this is our finding, there's a difference?
Yeah, so when you read a scientific journal, a lot of them will just spit out like a whole list of 95% confidence intervals. And you'll see like entire tables, right? Actually, that was like when I had you look at that blood pressure thing, right? There's one of the columns is just the 95% confidence interval. It's just the high bound and the low bound. And then all they're saying is, here's a bunch of numbers, okay? And I guess they're just assuming you know what to do with these things. I don't know. And I guess kind of, you kind of do, right? After this class, you kind of do. But there's a lot of, because of the way it's phrased, right? 95% confidence interval. There's a lot of room for misinterpretation and a lot of things that could be taken the wrong way or something. So I try to be specific in saying, this is expressing a degree of confidence. The true mean could actually very well be in or outside of that thing. So I don't know. Okay. All right. Is that okay? So at this point, I would happily take any just review questions from any of the stuff, any of the chapters we've covered so far.
I'll do the first one.
Okay. Yes.
This is based on the quiz number, last one.
The last one.
You answered for at most 10 left-handed people. Then we use 10.5 to include the 10, right? Can you give an example where we do not include that? We go to 9.5 instead. Can you just give a different?
If I say, okay, so the question said like, what is the probability that we have at most 10 left-handed people, right?
Right.
And then they said use normal approximation and with continuity correction. Okay, so in this case, wherever this thing is, I think the mean was at 15, and we're pretending to have a bar at 10, and we want to make sure we include the bar for 10, and not the bar for 11. Okay, so we want to include everything for 10 and everything below, so we draw our cutoff line at 10.5. Okay. When would we use 9.5? Okay, if I said what is the probability that we have less than 10 left-handed people?
Okay, thank you.
less than 10 means any number less than 10 but not including 10, right? So then our cutoff would be at, so this is 10, but we don't want that, so we draw our cutoff at 9.5.
Would that also apply if you were asking greater than 10?
Exactly. Do we have more than 10 or at least 10? Okay? Or 10 or more. Okay. So if I said 10 or more, then you go at 9.5. Or if I said at least 10, 9.5. But then I said more than 10, then you go 10.5 and higher. Yes?
For the first part of the same question,
Uh-huh.
A says what is the probability that you have at most one left-handed person?
Okay, at most
So-
one. So at most one
Yeah.
means you could have 0 or 1.
So you have to do 10, choose 0.
You have to do
1.
10, choose 0, etc., 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 plus 10, choose 1, etc., etc., etc.
So then if you were asking at most 5, you have to go.
Yeah, at most 5 for binomial is tedious. It'd be 10, choose 0, plus 10, choose 1, plus 10, choose 2, all the way up through 10, choose 5. Okay? Yes?
I know this is something that I should so know, but
That's okay.
is there, for the first question, the finding in this percentile?
Yes.
I know it involves the z-score, but I don't remember.
How?
Yeah.
How it works? Okay, so this is so finding the 65th percentile.
Yeah.
Okay. Is that thing still recording?
Looks like it.
Good battery there. Surprise. It's gonna shut off now, just as it said that. Okay. All right. So here we have a mean of 1152 and a standard deviation of 84. Now we are looking for the weight at the 65th percentile. That means we're going to have 65% shaded to the left of this line, and we just want to know what is this weight. Okay. So when we this is coming from the normal model. So we're going to use our normal table, and what we're looking for is in the normal table, we're looking for the z-score that gives me 0.65. Okay, so what z gives an area of 0.65 to the left. That's what we want to know. I'm looking for the number closest to 0.6500 in my normal table, and the number I see closest to that is 0.6517, which corresponds to the row 0.3 and the column 0.09. So I use z equal to 0.39. Is that good?
Yep.
Okay, and then so once I have that, now I can find this thing. Okay, I say z is equal to y minus mu over sigma 0.39 equals 1152 is equal to y minus 1152 over 84, and then I just solve for y. That's it. Yes.
Will you be available besides on Thursday before the midterm for office hours, or just through email and Facebook?
I'll probably have office hours from 5 to 6.
On Thursday?
On Thursday.
And no other days, though, right?
Yeah, I'm only on campus twice a week, Tuesdays and Thursdays. But Tuesday I'm really here just for my other class. I'm here, I'm out. So that's actually how it is for this one here. I get here and then that's it. Good luck. Or question?
I don't have a specific question, but what we covered today, is that gonna be on FaceTime?
Yes, so everything up through what we covered today. So, I mean, the only new thing we covered today were confidence intervals for the different